North Atlantic, October 1942. The graveyard. The ocean is not water. It is a vast, heaving plate of liquid steel, the color of a fresh bruise. The wind is a physical thing, a razor that screams across the swells, tearing the tops from the waves, and flinging needles of ice and salt into the faces of the men on watch. This is Convoy SC-107. 42 ships, heavy with the lifeblood of a war. Tanks for Montgomery's army in Africa, crated bombers for the 8th Air Force in England, cans of fuel, boxes of bullets, sacks of flour. A floating city of material crawling east at 8 knots. But the true cargo is time. Every ship that makes it to Liverpool buys Britain another day. Every ship that sinks subtracts one. Deep beneath the surface, in a world of silence, pressure, and recycled air, another clock is ticking. This world is green. The faint, ghostly glow of the gauges on the control room wall. The sweat-sheened faces of the crew, bathed in the sickly luminescence. This is U-402. The captain, Korvettenkapitän Siegfried von Forstner, peers through the attack periscope. He does not see ships. He sees targets. He sees a column of numbers in a ledger. He sees tonnage. His hydrophone operator had heard them hours ago. The rhythmic, clumsy beat of 42 merchant ship propellers. A sound like a herd of lame animals stumbling through the dark. Von Forstner is a patient man. He is a professional. He and his wolfpack, a group of 12 U-boats, have been shadowing the convoy, staying just over the horizon, waiting for the moon to set. Now the time has come. On the bridge of the SS Hennington, a rust-streaked freighter in the center of the convoy, the lookout sees nothing. He is staring into a blackness so absolute it feels solid. The only comfort is the sight of the other ships, dark shapes against a slightly less dark sea, and the flickering silhouette of a single Flower-class corvette, one of the convoy's 6 paltry escorts. It is a sheepdog trying to guard a sprawling, terrified flock against a pack of invisible wolves. The established solution is a failure. The doctrine of the convoy is a pact with mathematics, and the math is not on their side. The attack does not begin with a warning. It begins with a flash. A silent, brilliant, orange blossom of light erupts on the horizon, 5 miles away. A tanker. It is followed, seconds later, by the sound, a deep, hollow boom that travels through the water and vibrates up through the steel hull of the Pennington. It feels less like a sound and more like a punch to the gut. Then another flash, this one closer, and a third, closer still. Panic. The radio crackles with frantic, overlapping voices. Star shells burst high above, casting a dead, magnesium-white glare over the scene. The ocean is suddenly horribly illuminated. The sheepdogs, the little corvettes, are racing, dropping depth charges that send huge plumes of white water into the air. A furious but futile gesture. They are firing at sounds, at ghosts. The wolves are already among the flock. A torpedo strikes the ship directly in front of the Pennington. The explosion is not a boom. It is a metallic shriek, the sound of 1,000 tons of steel plate being torn apart like paper. The freighter, loaded with munitions, vanishes in a fireball that punches a hole in the night sky. The heat washes over the men on the Pennington's bridge. The shockwave rattles their teeth. Debris, white-hot and hissing, rains down into the sea around them. This is the unstoppable, terrifying nightmare, the German U-boat. It is not just a weapon, it is a system, a perfect, brutally efficient engine of destruction, guided by a cold, remorseless logic. And the men in the convoy are simply figures in its equation. The lookout on the Pennington finally sees it. A white line, a phosphorescent wake, moving impossibly fast through the black water. It is coming right for them. He opens his mouth to scream, but there is no time. The torpedo strikes them midship. The world becomes a chaos of noise and motion. The deck plates buckle, throwing men from their feet. A geyser of oil, seawater, and steam erupts from the engine room. The lights go out. The emergency klaxon begins to blare, a sound of pure mechanical terror. The ship is dying. It is groaning, twisting, breaking its own back. The captain gives the order, his voice strained, to abandon ship. Men scramble for the lifeboats in the dark. The Pennington is listing, going down fast by the bow. The freezing water is already washing over the main deck. This is the official doctrine of the merchant marine, a suicide pact. They sail on ships that are too slow, too poorly defended, and they die in numbers that are unsustainable. They die in the fire of the initial explosion, or they drown in the churning, oil-slicked chaos of the sinking. Or they make it to a lifeboat, only to die of exposure in the killing cold of the North Atlantic. This is the story we think we know about the war at sea. A story of grim statistics, of tonnage sunk versus tonnage built. A story of a war of attrition, where victory is measured in spreadsheets at the Admiralty in London and the Navy Department in Washington. A story of a battle against the U-boats. But this is not that story. This is the story of a different battle. A battle fought not with depth charges and destroyers, but with blueprints and welding torches. It is the story of how the entire, unshakable system of maritime warfare was turned on its head, not by an admiral, but by a blue-collar worker who had never seen the ocean. It is the story of an impossible problem, a war that was being lost, being solved by the most overlooked, unqualified, and unlikely person imaginable. This is the story of how a simple, contest-winning idea, born in the smoke and sparks of a California shipyard, did what the entire Allied Naval Command could not. This is the story of how one welder's insight cut a ship's life into a fraction, not in the water, but on the ways, and in doing so, changed the mathematics of the war forever. To understand the idea, you must first understand the crisis. By late 1942, the war was not being won. It was being lost, quietly, methodically, in the middle of the ocean. The strategic problem was Great Britain. The island was a fortress, a bastion, the final unsinkable aircraft carrier off the coast of Europe. But it was a fortress under siege. It produced almost nothing it needed to survive. Not food, not oil, not steel, not rubber. Every bullet fired, every gallon of gasoline burned, every loaf of bread eaten had to be brought in by sea. The Lend-Lease Act, signed by Roosevelt, was the promise. The American industrial machine, the arsenal of democracy, was churning out the goods. But the promise was worthless if it could not be delivered. The lifeline was a 3,000-mile conveyor belt of ships, and that conveyor belt was being systematically dismantled, piece by piece, by Admiral Dönitz and his U-boat fleet. This was the ticking clock. Britain was bleeding out. Its fuel reserves were measured in weeks. Food was rationed to near starvation levels. Its factories were grinding to a halt for lack of raw materials. The planned invasion of North Africa, Operation Torch, was in jeopardy. The future invasion of France was a logistical fantasy. The entire Allied war effort was slowly being strangled. Dönitz called it the Tonnage War, Die Tonnagegeschlacht, and he was a master of its brutal calculus. He knew he did not need to invade Britain. He only needed to sink ships faster than the Allies could build them. His U-boat crews were the elite of the German military. His captains were national heroes. From his headquarters in France, he looked at the shipping charts and saw victory. In this month alone, October 1942, his wolfpacks would sink over 100 Allied ships. A rate of 3 ships per day. Almost 600,000 gross tons sent to the bottom of the sea. The institutional arrogance was on the Allied side. It was the arrogance of tradition. The established solution was to build more ships, and America was building them. But it was building them the way ships had always been built. It was a craft, an art form, a slow, methodical, almost sacred process. Imagine a shipyard in 1941. It is a cathedral of old industry. The keel of a new freighter is laid. It is a single piece of steel, the spine. From this, a skeleton of ribs and frames is built up, piece by painful piece. Then, the skin. Thousands of individual steel plates, each one custom-shaped, heated in a forge, and hammered to fit. Each plate must overlap its neighbor, just so. And then, the rivets. The ship is held together by millions of them. A team of 4 men works on each one. A boy, the heater, plucks a white-hot rivet from a coke-fired forge with a pair of tongs and tosses it in a perfect, glowing arc to a man inside the hull, the catcher. He catches it in a lever cone. He uses his tongs to shove it into the precisely drilled hole. On the outside, 2 men, the riveters, attack it with a pneumatic hammer. Its deafening rat-a-tat-tat, the defining sound of the shipyard. They pound the hot metal, forming a perfect rounded head, clamping the 2 plates of steel together in a bond that is, in theory, as strong as the steel itself. 1 rivet, 4 men, 1,000,000 rivets per ship. It was a process that took time. It was a process that required skilled artisans, men who had been doing this for decades. It was a process that could build a single ship in 6 months, sometimes 8, sometimes a year. This was the system, the established solution. It was a system run by men who had built the world's navies, men from the great shipbuilding dynasties of the East Coast, of Scotland's River Clyde. They believed in their methods. They saw them not as slow, but as correct. They saw any attempt to speed up the process, to cut corners, as a path to shoddy workmanship, to ships that would break apart in the first storm. They were the experts, the masters of an ancient craft. and their craft was losing the war. The numbers were undeniable. For every new ship launched from an American yard after a 6-month ordeal, Dönitz was sinking 3, 4, sometimes 5 in a single week. The conveyor belt was not just being cut, it was moving backwards. The system was perfect in its own proud, traditional logic. It was also, fundamentally, a failure. It was failing to supply Britain. It was failing to enable the coming invasions. And it was failing to see the one industrial weapon it possessed that could break the stalemate. That weapon was not a new sonar or a faster destroyer. It was an idea, a revolutionary, deeply mistrusted, and supposedly shoddy technique that the old guard despised. The technique was welding, and the man who would unlock its true war-winning potential was not a naval architect with a degree from MIT. He was not a time and motion expert from the Ford Motor Company. He was a man with calloused hands and a high school education. A man who spent his days on his knees in the cramped, dark, double bottom of a ship's hull, a flickering torch in his hand, a leather mask hiding his face. His name was a mystery to the men in the boardroom. He was just a number on a payroll. But he was about to solve a problem that had stumped the greatest minds in the Allied command. He had noticed something, a simple, practical, on-the-ground observation that everyone else, in their rush to build ships, had completely missed. His name was lost to the official histories. He was not Henry J. Kaiser, the bombastic industrialist who was the face of the program, the man who grinned from the covers of magazines. He was not a naval architect from Gibbs & Cox, the prestigious New York firm that had designed the ugly, functional, and revolutionary ship they were building, the ship they called the Liberty. He was a man named Joseph, or perhaps John, a welder. He was one of thousands who had poured into the Richmond shipyards in California, a sprawling, chaotic city of mud, steel, and noise that had erupted on the edge of the San Francisco Bay. He was not a young man, not one of the boys who would otherwise be carrying a rifle. He was in his late 40s, his face a roadmap of fine lines etched by years of staring into the blinding glare of a welding arc, his hands thick and calloused, permanently stained with the grime of the yard. He was a quiet man, a man who had spent his life in the noisy, violent world of steel fabrication, and had learned that the less you said, the more you saw. He was, in every conceivable way, an overlooked part of the machine. He was not a leader. He was not an innovator in the eyes of the men in the clean offices. He was a pair of hands, a number on a time card, a man paid to melt metal with electricity. But Joseph, unlike the men in the offices, had a unique perspective. His office was the double bottom of a Liberty ship. It was a dark, claustrophobic labyrinth of steel, a space perhaps 4 feet high, reeking of ozone and burnt metal. It was the space between the outer hull and the ship's floor. And it was his personal hell. This was his eureka moment. It did not come in a flash. It was a slow, agonizing realization, built over hundreds of hours spent on his back, on his knees, contorted into impossible positions. He would be lying on a cold steel plate, the massive weight of the ship above him, the hull below him. His job was to weld the seams of the reinforcing frames to the underside of the ship's floor. It was called overhead welding. And it was a nightmare. Every law of physics was against him. He had to fight gravity with every inch of the weld. The molten steel wanted to drip, to sag, to fall, in burning, liquid gobbets onto his leather jacket, onto his mask. He had to move the electrode with a slow, painstaking precision, weaving a tiny, perfect circle to create a strong bead. It was an art that took years to master. It was physically exhausting. The smoke filled his mask, choking him. The light, reflected from a dozen angles, seared his eyes. And it was slow. A man who could lay down 30 feet of weld in an hour on a flat horizontal surface, what they called downhand welding, was lucky to get 5 feet done overhead. And the quality was never as good. The weld was never as deep, never as strong. It was a compromise, a necessary evil. He would lie there, the roar of the yard a distant thunder, and he would stare up at the geometric forest of steel above him, and he would think, this is wrong. This is backward. He would finish his shift, his muscles screaming, his eyes aching, and walk out into the vast, floodlit expanse of the yard. He saw the great cranes, the whirlies, lifting massive, 50-ton sections of bulkhead into place. He saw the teams of women, the famous Rosie the Riveters, swarming over the decks. He saw the process. They were building the ship like a house, from the foundation up. They laid the keel, the spine. They built the floor, the double bottom. Then they started adding the walls, the bulkheads, the decks, building it layer by layer, higher and higher, until it looked like a ship. It was logical. It was how ships had always been built. But they were not riveting. They were welding. And welding, he knew, was not carpentry. It was not masonry. It was a different kind of magic. It was a process of fusion, and it did not have to obey the same rules. The unique on-the-ground observation was this. The ship did not care if it was built right side up. Steel has no sense of direction. He watched the huge, pre-fabricated sections of the double bottom being lowered into place. He knew that in a few hours, he and dozens of other welders would have to crawl into that dark, cramped space to begin the slow, agonizing process of overhead welding. They would spend a week in there, turning the separate pieces into a single, solid floor. What if, he thought, you built it upside down? The idea was so simple, so childishly obvious, that he was sure he must be missing something. What if you took all the pieces of that double bottom section, the floor plate, the frames, the internal structures, and you assembled them on the ground, but inverted, flipped over? Every single weld that was now overhead would become downhand. A man could stand or kneel comfortably and lay a perfect, strong bead, letting gravity work for him, not against him. The work of 50 men working for a week could be done by 20 men in 2 days. The welds would be better, stronger, more reliable. And then, when it was all done, you would just flip it over. You would call over one of the giant whirly cranes, attach the cables, and lift the entire completed 100-ton section and lower it into the hull, right side up. He went to his foreman. The foreman was a man named Mac, a veteran of the East Coast shipyards, a man whose ears still rang with the sound of the rivet guns. He had been brought west to teach these California amateurs how to build real ships. He saw welding as a newfangled, slightly suspect shortcut. He did not trust it. He trusted the old ways. Joseph tried to explain his idea. He was not an eloquent man. He drew a diagram in the dirt with the toe of his boot. "Sir, if we build the floors upside down." Mac looked at the drawing. He looked at Joseph's earnest, smoke-stained face, and he laughed. It was not a kind laugh. It was the contemptuous bark of a man who had heard it all. "You want to do what?" he asked. "You want to take a 100-ton piece of a ship, a piece that has to be perfect, and you want to build it ass backwards and then flip it over with a crane?" He said, "Son, we are building ships here, not pancakes." He kicked the drawing in the dirt, erasing it. He said, "A crane lift like that is dangerous. What if the welds fail? What if the whole thing buckles? What if you drop it? You could kill 100 men. You could set the whole schedule back a month." He said, "Your job is to weld. My job is to think. Now get back to it." He was dismissed. He was ignored. He was a welder who had tried to be an engineer, and he had been put back in his place. The established leadership, the voice of tradition, had not just rejected his idea, it had declared it dangerously insane. This was the catalyst. It was not just the foreman's scorn. It was the radio. It was the newsreels they showed in the mess hall during lunch. It was the grim nightly reports from the BBC, crackling over the shortwave. It was the lists of ships posted on the yard bulletin board. Overdue, presumed lost. The name of convoy SC-107 was on that list. 15 ships, gone in 2 nights. That was 3 months' work for this entire shipyard, erased from the ocean in 48 hours. He felt the ticking clock not as a strategic problem, but as a moral one. The men on those ships were dying because the ships were not getting there fast enough. And he, Joseph, was being forced to build them slowly, stupidly, wastefully, because of one man's pride. The system was not just failing, it was killing people. He was going to break the rules. He did not plan a rebellion. It happened organically. It was a conspiracy of the overlooked. He found a few other welders, men who had shared his hell in the double bottoms, who knew he was right. He found a crane operator, a young man from Oklahoma, who still treated the giant whirly crane like a magnificent toy and was willing to try anything. He found a night shift supervisor, a younger man, ambitious and frustrated with the old guard's rigid thinking. This was his unauthorized test. It was a secret, whispered in the noise of the yard, planned with hand signals and sketches on scraps of steel plate. They chose their target, a small, non-critical subassembly of a ship's forward section, a piece of the floor, maybe 20 tons. According to Mac's schedule, it would take 2 full shifts, 40 man-hours of difficult interior welding to complete. They waited for their chance. One night, when the graveyard shift was thin, when the main supervisors were home in bed, they went to work. They did not clock in for this job. This was off the books. This was their own time. This was the new tactic, in miniature. They laid the floor plate down on the great concrete slab of the assembly yard, but they laid it upside down. Then, using a smaller yard crane, they began to lower the internal frames and girders into place, tack welding them to the inverted floor. It was a strange, skeletal sculpture, an abstract piece of a ship that looked all wrong. Then, the welders descended, Joseph and his small team. But they were not crawling, they were walking. They knelt on the steel, their bodies in positions of comfort, of stability. The welds they had to make were all downhand, the long, straight, beautiful seams. They moved with a speed and confidence that was impossible in the cramped confines of the hull. The hiss and crackle of their electrodes was constant, efficient. The molten metal flowed like syrup, pooling into perfect, deeply penetrated beads. There was no dripping, no sagging. There was only the steady, rhythmic creation of strength. They worked for 4 hours. The job that was supposed to take 2 shifts was done, and it was done perfectly. Now came the test, the it works moment, the part that had made Mac laugh. The flip. The young crane operator was in the high cab of the Whirly, looking down. He had positioned the crane directly over the strange upside-down assembly. Heavy steel cables with 4 massive hooks were lowered. Joseph and his team attached them to the reinforced lifting points they had welded onto the structure. The operator got the signal. He engaged the clutch. The cables went taut with a groan. The electric motors of the crane whined, their pitch rising. The 20-ton assembly shuddered. It lifted, an inch, then a foot off the concrete. It was holding. Now for the delicate part. The operator, a prodigy at his controls, began to boom out and swing the crane's arm while simultaneously hoisting the cables. The huge steel structure rose, tilted, and began to turn in midair. It was a slow, terrifying, deeply impressive ballet of industrial power. It swung over an empty section of the yard, 100 feet in the air, a massive skeletal wing against the night sky. It rotated a full 180 degrees. It was now right side up. The operator swung it back, lowering it with the precision of a surgeon, onto a set of wooden blocks. It settled with a deep, solid thud. Silence. Joseph and his team walked toward it. They looked at their creation. It was perfect. The seams were clean, strong, flawless. They had done it. They had built a piece of a ship in a quarter of the time, and the quality was twice as good. The night shift supervisor was standing there, a stopwatch in one hand, a clipboard in the other. He looked from the finished piece to Joseph. His face was pale in the harsh floodlights. He could not form words. He just shook his head, a slow, continuous motion of pure, unadulterated shock. He was staring at a miracle. The proof was right in front of them, solid and made of steel. The stupid idea was not just smart. It was a revolution. And they had just committed a profound act of industrial treason. The sun was coming up, and soon Mac, the foreman, would be arriving for his shift. The first light of dawn was not soft. It was industrial. A harsh, gray illumination that caught the dust and smoke hanging in the air, revealing the sprawling geometry of the shipyard in stark relief. The sound of the yard was a sleeping giant beginning to stir. The distant clang of a hammer, the cough and rumble of a diesel engine, the shrill whistle calling the day shift to their stations. And in the middle of the assembly slob sat the 20-ton section of floor, a silent steel rebuke to the entire history of shipbuilding. Mac, the foreman, saw it from 100 yards away. He was walking his usual route, a thermos of black coffee in one hand, his eye already scanning the cranes, the hulls, the workflow, looking for problems. And then he saw it. The section. It was not supposed to be there. It was supposed to be a collection of plates and frames, waiting for the welders to begin their slow, painstaking work. Instead, it was whole, finished, perfect. He stopped walking. His mind, a finely tuned machine of schedules and processes, ground to a halt. It was an anomaly, a break in the universal laws of the yard. He walked closer, his pace quickening. He saw Joseph and the small team of night shift welders standing near it, along with the young supervisor, Clark. They were not working. They were waiting. They looked like conspirators caught in the act. Mac's face, a weathered map of skepticism, darkened. He did not see a miracle of efficiency. He saw a violation. He walked right up to the steel assembly and ran his hand over a weld seam. It was flawless, a smooth, even bead, better than anything his day shift crew could produce on that section. This was the source of his fury. It was not just that they had disobeyed him. It was that their disobedience had proven him wrong. He turned to Joseph, his voice low, a growl that cut through the rising noise of the yard. He asked him what in the hell he thought he was doing. This was the first tremor of the boardroom conflict, played out not in an office, but on the cold concrete of the yard floor. Joseph, the quiet welder, did not answer. He just looked at the finished work. The work spoke for itself. It was Clark, the night supervisor, who stepped forward. He was young, barely 30, a man with a slide rule on his belt, and an engineering degree that Mac held in deep contempt. Clark was the advocate. He was the translator who could turn Joseph's blue-collar insight into the white-collar language of numbers. He told Mac they had tried a new assembly sequence. He held up his clipboard, showing the timings, the manpower, the astonishing reduction in hours. He said, "We did in 4 hours what your schedule budgeted for 40. Mac did not look at the clipboard. He looked at the massive whirly crane, its hook still hanging near the assembly. He looked at the scuffed marks on the concrete. He understood. He asked Clark, his voice dripping with venom, if he had flipped it. Clark said yes, they had. This was the crime, the act of industrial heresy. Mac saw the recklessness, the insane gamble with 100 tons of steel. He saw the potential for a catastrophic failure that could have crushed a dozen men, destroyed a crane, and brought the entire yard to a standstill. He did not see the triumph. He saw the risk. He told Clark he was a fool. He told him he was going to have him fired, along with this whole crew of hotshot welders. He pointed a thick, grease-stained finger at Joseph and said that men like him were a menace. They had no respect for the craft, for the danger, for the right way of doing things. This was the system fighting back. It was tradition, embodied in one angry foreman refusing to accept evidence that contradicted its core beliefs. The skeptical general had drawn his line in the dirt. But Clark did not back down. He was the desperate advocate. He had seen the miracle. He had timed it. He knew what it meant. He told Mac, respectfully but firmly, that he would not be firing anyone. He said he had authorized the test. He said it was his responsibility. And he said he was taking his clipboard and this new data directly to Mr. Henderson, the yard superintendent. He was going over Mac's head. This was the gamble. Clark was betting his entire career on this one, unauthorized, upside-down piece of a ship. He was making an enemy of a powerful, respected foreman and forcing a confrontation with the highest levels of shipyard management. He was taking Joseph's quiet revolution and turning it into an open rebellion. The boardroom was not a room. It was a long, temporary wooden building set on a hill overlooking the chaos of the yard. From his window, Yard Superintendent Henderson could see it all. The 6 slipways, the towering cranes, the ant-like swarms of workers. His office was an island of quiet, of polished wood and nautical charts, a world away from the noise and the grime. He was a man from the East Coast, sent by the Maritime Commission to bring order to this new, explosive West Coast operation. He was a man who believed in blueprints, in chains of command, in the established, time-tested methods of the Newport News and Four River shipyards. He was the system. Clark stood before his desk. He had Mac with him, who Henderson had summoned to give his side of the story. Joseph was not there. This was a battle for the white-collars now. His idea was on trial, but he was not allowed to testify. Clark laid it out. He was calm, professional. He presented the data, the man-hours saved, the improved quality of the welds, the potential for a cascade of efficiencies across the entire assembly line. He used words like workflow optimization and critical path analysis. He was translating Joseph's grunt-level insight into a language Henderson would understand. Mac gave his rebuttal. He spoke of tradition, of safety, of the unknown stresses on a structure that was welded in one position and then flipped into another. He called it a circus stunt. He said it was a reckless, undisciplined shortcut that would lead to cracked hulls and broken ships. He argued that these Liberty ships were already a compromise, a flimsy, disposable vessel built without the integrity of a proper riveted hull. This new method, he said, was taking an already shoddy product and making it worse. It was not just stupid, it was ungentlemanly. It was a betrayal of the shipbuilder's art. Henderson listened. He was a shrewd man. He was not a fool. He understood the numbers Clark was presenting. The potential was staggering. But he also understood Mac's fear. It was the institutional arrogance of the entire shipbuilding industry. The belief that their way, the old way, was the only way because it had always been the way. He saw the politics. If this idea from a no-name welder and a junior supervisor was adopted, it would be an admission that the entire brain trust of naval architects and veteran shipbuilders had been wrong. He leaned back in his chair, the leather creaking. He looked out the window at the half-finished hull on Way 4. It was weeks behind schedule. He looked at the latest tonnage reports from Washington, the numbers circled in red ink. He was squeezed between the institutional pride of his profession and the existential demands of the war. He told Clark the risk was too great. The potential for a catastrophic failure during the lift of a main hull section was a nightmare. A 100-ton piece of steel falling from a crane would be a disaster from which the yard's reputation and his career might never recover. He was about to dismiss the idea, to side with tradition, to tell Mac to enforce discipline on his crews. This was the moment. The damn the rules decision had to be forced. Clark, seeing his gamble about to fail, played his last card. He was desperate. He stopped talking about efficiency and started talking about the war. He mentioned Convoy SC-107. He said that for every day they shaved off the build time of a single ship, they were putting a vessel on the ocean that might save 5,000 men. He asked Henderson to calculate the risk of that. He said the old ways, Mac's ways, were safe, they were comfortable, and they were losing the tonnage war. He said the real risk was not in trying something new. The real risk was in doing nothing. He then made his final desperate proposal, the gamble. He did not ask to change the entire yard's procedure. He asked for one ship, just one, Hull 440, a ship whose keel had just been laid. He asked Henderson to let him and his team build it their way. He said they would pre-assemble every possible section upside down. They would flip the floors, the bulkheads, the deckhouses. He said he would take personal responsibility for the entire project. And he made a promise, a wild, unbelievable boast. The current record for a finished Liberty ship, from keel laying to launch, was 46 days, a time the rest of the world already considered a miracle. Clark promised Henderson he could launch Hull 440 in 25. Mac snorted in derision. It was impossible. It was the promise of a madman. Henderson was silent for a long time. He stared at Clark, this young, intense engineer who was staking his entire future on such a ludicrous claim. He looked at Mac, the face of stubborn, proud, and failing tradition. And he made a decision. It was not the decision of a visionary. It was the decision of a desperate man with no other good options. He said yes. But it was a yes with a razor's edge. He authorized the experiment on Hull 440. He gave Clark full authority over its assembly, creating a special projects team, pulling Joseph and the other welders from the night shift to be its core. He would have the full support of the yard's resources. But it was a public gamble. The entire shipyard would know about Hull 440. It would be known as the upside-down ship, as Clark's folly. And Henderson gave him his terms. He was not just expected to meet his 25-day deadline, he was expected to beat it. And if there was a single major safety failure, a single dropped section, a single cracked weld discovered by the inspectors, the project would be terminated on the spot. Clark would be fired, the welders would be reassigned, and the entire insane idea of building ships like pancakes would be buried forever. The gamble was made. A career, a revolutionary idea, and the hopes of building ships faster than the U-boats could sink them, all now rested on the steel plates of a single, ugly freighter. It was Joseph's idea against the entire weight of history. The unauthorized test was over. The real battle, the one that would take place in the full glare of the shipyard lights, was about to begin. Hull 440 was no longer a number. It was a spectacle. Slipway 4 became a theater of war, but the enemy was the clock. The entire shipyard, from the apprentices to the superintendents, felt the gravity of the gamble. The story of Clark's folly had spread through the yard like wildfire. During their breaks, riveters from other hulls and painters from the finishing docks would wander over, their faces a mixture of curiosity and morbid expectation. They were there to watch the circus stunt. They were there to see the pancake flip. And at the edge of the slipway, every morning, stood Mac. He was a statue of scorn, his arms crossed, his clipboard held like a shield. He was the arrogant advance of the old guard, the physical embodiment of the system's doubt. He was not there to help. He was there to watch, to document, and to be proven right when the entire ludicrous experiment came crashing down. The new unlikely tactic began not with a bang, but with a ballet. The first great test was the aft double-bottom section. 150 tons of steel, a sprawling section of the ship's floor as wide as a city street, assembled upside down on the concrete slab. Joseph and his team had swarmed over it for 3 days, their welding arcs a constant, furious blizzard of blue-white light. They had worked in the open air, standing, kneeling, moving with a freedom and speed that was alien to the dark, contorted hell of conventional shipbuilding. Now it was time for the flip. The entire day shift seemed to hold its breath. Clark stood near the base of the massive whirly crane, his face pale, his hands clenched into fists. Joseph was with his crew, standing back at a safe distance, his expression unreadable behind his leather mask. 2 whirly cranes working in perfect unison were needed for a lift this size. The operators, the young prodigy from Oklahoma and a seasoned veteran, had rehearsed the move with a model. But this was real. This was 150 tons of steel that, according to Mac, was held together by shoddy, rushed, upside-down welds. The cables went taut. The motors of the 2 cranes groaned, a deep, resonant harmony of immense power. The massive steel slab shuddered, and then, with an agonizing slowness, it lifted from the ground. It rose 10 feet, 20 feet, 50 feet, a vast, flat shadow ascending into the California sky. Mac's jaw was tight. He was watching the lifting points, the welds around the massive steel hooks, waiting for the telltale shriek of tearing metal, the catastrophic failure he had predicted. But the welds held. The two crane operators, communicating through a series of sharp whistle blasts, began their terrifyingly delicate dance. One crane boomed out while the other held its position. The slab tilted, rotating on its axis. It was no longer a floor, it was a wall, a cliff of steel hanging suspended in midair. It continued to turn, a slow, majestic, and utterly silent pirouette against the sky, until it had completed its 180-degree rotation. It was right side up. A sound rippled through the crowd of onlookers, a collective exhalation of breath. It was not a cheer, it was a gasp of pure, unadulterated shock. The crane swung the completed section over the slipway, lowering it with millimeter precision onto the keel blocks of hull 440. It settled with a deep, authoritative boom that echoed through the yard. The first and most difficult piece of the puzzle was in place. It had been built in 3 days. The old method would have taken 2 weeks. Mac did not move. He stared at the section, now resting perfectly in the cradle of the shipway. He could not see any flaws. He could see only the impossible speed, the undeniable success. His bafflement was a cold, hard knot in his stomach. This was not supposed to work. The first day's victory was not a fluke. It was the new tempo, the brutal, relentless rhythm of the upside-down build. The ship began to grow, not like a building, layer by layer, but like a living thing, assembling itself from massive, prefabricated limbs. Section by section, the floor of the ship was laid down, each piece built and welded on the ground in a fraction of the time, then flipped and lowered into place. Joseph was the quiet center of the storm. He was no longer just a welder. He was a choreographer of steel. He moved between the assembly slabs and the growing hull, his eyes seeing things no one else could. He would stop a team, make a mark with a piece of soapstone, suggesting a change in the welding sequence, a different way to brace a section before a lift. He was not giving orders. He was sharing a new kind of knowledge, an intuitive, practical engineering that had been born in the dark confines of the double bottom. The welders, his welders, revered him. They worked with a furious pride, knowing they were part of the rebellion. The enemy's confusion deepened. Mac and the other foremen would walk the hull of a conventionally built ship, like the one on Slipway 3, and hear the slow, intermittent crackle of a few dozen welders working in the dark. Then they would walk over to hull 440 and see hundreds of men working simultaneously in the open, their welding arcs a constant, blinding glare. The sheer volume of work being done per hour was an order of magnitude greater. It was the difference between a craftsman's workshop and a full-scale factory. By day 10, the impossible had become routine. The hull was plated to the waterline. The bulkheads, the great interior walls of the ship, were being assembled flat on the ground like pieces of a giant's puzzle, then lifted and slotted into the hull in single massive pieces. The panic began to set in among the traditionalists. It was not a panic of fear, but of obsolescence. Their craft, their lifetime of accumulated knowledge, was being rendered irrelevant in a matter of days. They began to swarm the ship, the inspectors, the quality control men, the disciples of Mac. They were looking for the fatal flaw. They tapped every weld with hammers, listening for the hollow sound of a bad bond. They brought in X-ray machines, a new and cumbersome technology, to peer inside the steel. They were hunting for the lie, the shoddy workmanship that had to be the secret to this impossible speed. They found nothing. They found the opposite. The welds on hull 440 were not just as good as the welds on other ships, they were better, deeper, more uniform, more consistent. Joseph's simple insight that gravity was a tool was being proven in every microscopic grain of the steel. The new tactic was not a shortcut that sacrificed quality. It was a fundamental improvement that created both speed and strength. The climax of the construction was the lift of the forward superstructure, the deckhouse. The entire 5-story structure, containing the bridge, the radio room, the officers' quarters, was assembled as a single 200-ton block on the ground. It was fully plumbed, fully wired, with windows and doors already installed. On other ships, this was built on the deck, piece by agonizing piece, a process that took weeks. Clark and Joseph planned to install it in an afternoon. This was the final defiant act of their industrial heresy. Mac stood with Superintendent Henderson, watching from the observation platform. This, Mac had argued, was the lift that would break them. The structure was too complex, too top-heavy. The lifting points would tear away. It was a gamble too far. The giant cranes dipped their heads, their cables attaching to the Leviathan block of steel. The motors whined, straining against the immense, unprecedented weight. The deckhouse lifted, cleared the ground, and began its slow, majestic ascent. It swung out over the completed hull of Hull 440, a floating building, a castle in the air. For a moment, it seemed to float, a perfect, impossible object suspended between the earth and the sky. Then it was lowered. It descended into the chaos of the deck, guided by dozens of men with guy ropes. It settled into its pre-marked position with a shudder that vibrated through the entire slipway. Men swarmed it instantly, the welders moving in to fuse its base to the main deck, the electricians and pipe fitters already connecting the pre-installed arteries to the body of the ship. The tactic was proven, decisively, in the heart of the battle. Henderson turned to Mac. He did not say a word. He just looked at him. Mac stared at the ship. It was no longer a collection of parts. It was a vessel, a complete, whole, and almost living thing. He looked at the calendar board at the head of the slipway. It read Day 20. The final validation came from the men with the clipboards. The inspectors from the Maritime Commission and the American Bureau of Shipping, the ultimate arbiters of quality, the men who had the power to condemn a ship before it ever touched the water. They had been watching Hull 440 with deep suspicion from the beginning. Now, they descended for their final, top-to-bottom inspection. They spent 2 full days crawling through every corner of the ship. They went into the double bottoms, the place where Joseph's revolution had been born. Instead of finding the compromised, difficult welds of a normal ship, they found perfect, machine-like seams. They x-rayed the hull plates. They pressure-tested the tanks. They checked every wire, every pipe, every rivet in the few places they were still required. Their report landed on Henderson's desk on the morning of Day 23. It was a document of profound bureaucratic shock. Hull 440 did not just meet the standards, it exceeded them in every measurable category. It was, according to their meticulous and unforgiving analysis, the best-built Liberty ship that had ever been presented for inspection. It was stronger, more durable, and more likely to survive the brutal punishment of the North Atlantic than any of its conventionally and slowly built sisters. The title of the contest had been won. The welders' idea had not just cut production time, it had created a better ship. The impossible promise Clark had made in Henderson's office had not just been met, it had been shattered. The word went out. Hull 440 was cleared for launch. It would be christened in 24 hours, on Day 24. They had not just broken the previous record of 46 days, they had cut it in half, with a day to spare. The baffled system had no argument left. The proof was there, floating in the slipway, a 10,000-ton testament to the genius of an upside-down idea. The stage was set for the final act, to see if the thing would actually float. The launch of Hull 440, christened the SS Robert E. Peary, was not a secret. It was a declaration of war, not on Germany, but on the clock. The news of its impossible construction time, 24 days from keel to water, was not just a line item in a production report. It was a weaponized statistic, a piece of information deliberately leaked to the press, broadcast on the radio, and sent crackling across the Atlantic. It was a message intended for one man. In his headquarters on the French coast, Admiral Dönitz saw the numbers, and for the first time, the cold, calculating architect of the Tonnage War felt the icy touch of doubt. His entire strategy, his path to victory, was built on a single, elegant equation. He had to sink ships faster than the Allies could build them. For 2 years, the equation had been beautifully, brutally in his favor. His wolfpacks were a scalpel, bleeding Britain dry, ton by excruciating ton. Now, the numbers were beginning to lie. The intelligence reports from his spies in American shipyards spoke of a new, frantic pace, but the figures were unbelievable, dismissed as propaganda. A ship built in 2 months was a feat. A ship in 1 month was a miracle. A ship in 24 days was an absurdity, a statistical impossibility. And yet, the ships were appearing. Convoys that should have been shattered and depleted were arriving in Liverpool with their ranks mysteriously replenished. The conveyor belt, which he had so expertly severed, was somehow repairing itself, moving faster, carrying more. His perfect system, his engine of attrition, was being met with an impossible, inexplicable resilience. The German high command was baffled. Their best minds were focused on the battle at sea, looking for the Allied innovation that was changing the math. Was it a new form of sonar? A breakthrough in airborne radar? A new depth charge? They were looking for a weapon. They were searching for a new piece of technology in the middle of the ocean. They never thought to look for the answer in the mud and sparks of a California shipyard. They could not conceive that their entire war effort was being dismantled not by a destroyer escort, but by an idea. The enemy's baffled after-action report was a collection of question marks. They were being defeated by a process. They were being drowned by an endless tide of welded steel, a flood of ships born from an idea so simple, so practical, and so utterly alien to their way of thinking that they never even saw it coming. The war of attrition was lost not when the Allies started sinking more U-boats, but when they started building ships upside down. And the man who had authored this victory? The hero who had handed the Allies their war-winning weapon? Joseph was not on the stage during the christening of the Robert E. Peary. He did not shake hands with the visiting senator. He did not have his picture in the paper. He stood in the vast crowd, a man in a worn leather jacket, indistinguishable from the thousands of other welders, fitters, and riggers. He watched the bottle of champagne shatter against the bow. He felt the ground tremble as the enormous hull, his hull, began to slide down the ways. He watched it hit the water, sending up a great celebratory wave. He watched it float. It did not crack. It did not break. It sat perfectly on the water, ugly, functional, and strong. He felt a quiet, profound satisfaction, a feeling deeper than any medal or public praise. Then he turned, walked back to the yard, and started thinking about the next hull. After the war, the noise stopped. The Richmond shipyards, a city of 50,000 workers at their peak, fell silent. The whistles no longer blew. The giant whirly cranes stood like skeletal sentinels against the sky, rusting in the salt air. The frantic 24-hour rhythm of the war effort was replaced by the whisper of the wind and the cry of gulls. Joseph did not seek a new stage. He went back to his life. He was a man who worked with his hands. He may have opened a small fabrication shop, fixing farm equipment, or building custom gates. He might have simply gone to work for another company, a quiet, reliable man who could lay a perfect bead of weld on anything you put in front of him. He did not write a memoir. He did not give speeches. He never claimed credit for the revolution he had started. His name is a footnote in a few obscure academic papers on wartime industrial production, a historical maybe. He was a man who had seen a stupid way of doing things and had found a smarter way. The problem was solved. The war was over. For him, it was that simple. His quiet life was the testament of a man who did not need history to know his own worth. The proof was not in a book. It was in the thousands of ships that had made it across the ocean because of him. The moral is this: doctrine is the most dangerous enemy of all. It is the arrogance of the expert, the institutional belief that the established way is the only way. The Allied High Command, the great naval architects, the titans of the shipbuilding industry were all brilliant men, and they were all trapped inside the same beautiful, traditional, and fatally flawed idea of what a ship was and how it should be built. They saw shipbuilding as a craft, a legacy handed down through generations. Joseph, the man on the ground, the uncredentialed worker, was free from the burden of that legacy. He was not a shipbuilder, he was a welder. He did not see a sacred vessel, he saw a box made of steel plates. And his unique, practical, on-the-ground perspective allowed him to ask a question so simple that the experts could never have conceived of it. What is the fastest way to weld a box? The answer, building it in pieces and upside down, was not a compromise. It was a superior method in every way. It was faster, stronger, safer, and more efficient. It was a victory of profound, blue-collar common sense over educated, white-collar dogma. The greatest strategic weapon of the Tonnage War was not a new engine or a new hull design. It was a change in process. It was the realization that the tactics of the factory floor were just as important as the tactics on the battlefield. The war was won not by the men who designed the ships, but by the man who finally figured out how to build them. And this is the full circle. The unauthorized idea, the circus stunt that was dismissed and laughed at by the guardians of tradition, is now the unquestioned, universal, and invisible doctrine of the modern world. After the launch of the Robert E. Peary, the revolution was absolute. The upside-down modular method swept through every emergency shipyard in the nation. It was not just adopted, it was evangelized. Teams from Richmond were sent to other yards to teach the new religion. Production schedules were not revised, they were torn up and rewritten. The 24-day ship became the new benchmark. Then the benchmark was broken, and then it was annihilated. A ship in 10 days, a ship in 7. Finally, in a stunning display of industrial might that served as the final death blow to Dönitz's hopes, the SS Robert E. Peary itself was built from keel laying to launch in an unbelievable 4 days and 15 hours. The Tonnage War was over. The equation was irrevocably broken. The trickle of ships had become a flood, a torrent of steel that washed over the Atlantic, supplying Britain, fueling the invasion of Europe, and changing the entire strategic landscape of the war. Today, the legacy of that quiet welder is everywhere, and it is nowhere. It is in every supertanker carrying oil from the Middle East, in every massive container ship linking the economies of entire continents, in every nuclear aircraft carrier that projects power across the globe. They are all built this way. They are not built from the keel up. They are assembled, like a child's building blocks, from massive pre-fabricated modules called grand blocks. These sections, weighing thousands of tons, are built in vast automated fabrication sheds, often miles from the sea. They are fully outfitted, with pipes, wiring, and machinery already installed. And then they are carried to the dry dock, lifted, flipped, and welded into place. The modern shipyard is Joseph's idea, magnified by technology and perfected by time. The quiet, desperate, unauthorized test he conducted in the dark of a California night has become the fundamental grammar of modern heavy industry. The welder's folly is now the standard operating procedure for the entire global economy. It is a revolution that has become so ubiquitous, so foundational, that it is now completely taken for granted. It is the quiet, anonymous, and world-changing legacy of a man who simply looked up at the ceiling of his cramped, dark office and decided there had to be a better way.